Okay, thanks for having me. I would like to talk to you with a short summary of what I call our suicide war with nature, or Welcome on the Titanic, and a special place for scientists, the Watchtower. Uh, want to explain in this short introduction why I li- like to, I want to explain to you that it's a war which is far more complex than just the CO2 problem one is talking about. And obviously, it can only be a short introduction or the tip of the iceberg of the problem we are facing. Now, I would like to go through 4 points. First, giving some background material about our war against nature. What I mean is obviously suicide. And well, there's so much being discussed at United Nations meeting, European Union, and so on. And I think nobody has ever better summarized it than Chief Joseph, an American Indian leader from in 1879. I have heard talk and talk, but nothing is done. Good words do not last long unless they amount to something. Words do not pay for my dead people. They do not pay for my country now overrun by white men. Now, if you have time, I suggest that you take the look at the full speech Chief Joseph was giving in New York, or in Washington in this year. Anyway, so I would like then to come to this human impact, which is far too large. So, and what it means, what the real overshoot problem is. And obviously, from this, it follows that growing CO2 levels are very dangerous, but it's not the only iceberg created by our civilization. And then some ideas on how to terminate the suicidal war against our life support system. And obviously, can be summarized in short, we have to slow down the destruction of our life system and start to repair what has been damaged. And then finally, what I could imagine the responsibility and role of scientists and especially physicists could be in this situation to limit or just come to a slowdown and finally an end of this suicidal war. Okay, and all right. So I was actually surprised when I searched a little bit around that I'm not the only one who's talking about a war on nature, and I was surprised to see, for example, the chief of the UN mentioning humanity waging war on nature. UN chief told the world on this UN Biodiversity Summit, and this was in 2010, or the photos from 2010, and this biodiversity conference was in 2020. And you see here a picture from some mountains in this former jungle of Indonesia, and now by logging for wood, somehow for timber, basically how the whole area gets destructed. And this picture, I believe you have seen, this was from another United Nations Food System Summit, and this guy there, apparently the speaker says the world leaders embrace the ideas that war against nature must end. And you can see here this picture, which I guess some of you have seen. So you see these kind of farming machines in the former area of the tropical rainforest in Brazil, and how this is being used for soybean production. All right. Then recently there were some articles, for example, from Le Monde, showing a picture from Spain where kind of a desert is created, and it says drought in Spain, where large amount of our food is coming from, by the way. If water management doesn't change, the country will become a desert. And similar, you can go to many other places in the world, but I like to actually show how it affects rich countries as well. And this is here, drought hits the Midwest, threatening crops and the world's food supply. And you can imagine that not much is growing in such areas, even if there are some kind of windmills or similar things behind. All right, but let's go a bit back to the origin. And in 2012, there was a special United Nations meeting in Rio de Janeiro, and it was the so-called Rio +20 meeting, +20-year meeting. In 1992, there was a huge meeting where governments from all around the world came and said, we do something. And so every 20 years, they want to kind of summarize what has happened. And when you go through it, some are through some few headlines, media headlines. So I took here the Guardian always, but it was in the preparation for this 2012 summit. I think just a week before, there was something on the don't wait for disappointment from the bureaucrats. Today, technocratic politicians will only ever lead from behind once the critical mass of people have already shown the way. And then you can see the Brazilian leader Rousseff was pardoning illegal deforestations, and further many treaties to save the earth, but where's the will to implement them? Or return to Rio, second chance for the planet. This was nature, which is maybe closer to many of us. Or nature again, African land grabs hinder sustainable development. Sales of forest land to corporation are dispossessing inhabitants and harming ecosystems. And then when the conference was over, Guardian said, after Rio, we know governments have given up on the planet. So we can say that we had at least 40 years of mega meetings at United Nations, the G8, the G20, European Union, and on and on and on, and with many good intentions and many good words. But I think if we compare the world today with what we had seen 20 or 40 years ago, the global policies made our economy and our world less sustainable. Just to prove this, somehow you find this, for example, in this UNEP publication, Global Environmental Outlook from 2012. Population increased from 3.9 billion in 1972 to 5.5 billion in 1992 to 7 billion in 2012. So 1.6 billion people more and 1.5 billion more in 2018. And actually, just last year, we crossed the 8 billion number. And apparently, if you follow these trends, 8.5 billion people want to live in 2032. Then our non-renewable energy consumption almost doubled between 1972 and 2012. When you go for CO2 levels in the atmosphere, you can see 330 ppm when this first meeting in Stockholm took place from United Nations started that we have a problem. It increased by 30 ppm in the next 20 years. And then when everybody said, oh yeah, we have a problem, from 1992 to 2022, it increased by 60, almost twice as much as in the 20 years before. And actually, just in December, we are now at 422 ppm. Furthermore, then it was there were so-called Millennium Development Goals, were defined in the year 2000 by the United Nations. And it is known that it was a total failure. But instead of trying to find out what the failure was, they were just replaced by 17 Sustainable Development Goals, just changing a little bit the name. And when you look at 8 years later, the Sustainable Development Goals, which should be achieved by 2030, are so far a total failure in all respects. And when you look in the document, the pressure on biodiversity continues to increase. Habitat loss and degradation from agriculture, infrastructure development, overexploitation, pollution, invasive alien species remains in predominant threats to this biodiversity, for example. And furthermore, they say economic growth has come at the expense of natural resources and ecosystems. Many terrestrial ecosystems are being seriously degraded because land use decisions often fail to recognize non-economic ecosystem functions and biophysical limits to productivity. Now, unfortunately, almost all scientists are very silent, and there are few sections. And when, for example, you can look in this article on the Lancet, which is not particular physicist journal, but there he explains why the Sustainable Development Goals will fail. And this was in 2014, and probably nobody has ever heard about this text and why this scientific publication was sort of ignored. Now, let me show you again these kind of diagrams, which perhaps is the left one you have seen. This is the CO2 measurement, how it increases, and you see the annual fluctuation and how it grows and grows and grows. And now when you look at it, I mean, there's some kind of maybe stupid coincidence, but when you think from 1956 to 1972, you have a certain slope in this area, and it would have continued like this. But then we had the United Nations meeting in 1972, and we get another slope until 1992. And from 1992 to 2012, we get another slope. And if you want, you can even see another strong rising slope. Now, there's another part of this climate catastrophe which comes from the methane contribution. And if sort of you look at the numbers, you find that the methane of CH2 is about a 25 times stronger greenhouse gas. Now there are some details how this is calculated and what the lifetime of the methane in the atmosphere is compared to CO2 and so on and so forth. But overall, they argue at this United Nations meeting that it's about 25 times stronger. Now, when you see it, and perhaps you remember there was some kind of plateau-like things when many discussions happened and said, okay, so methane is not a problem anymore. And since 2006 or 8, it started again very rapidly. And many big reasons for these methane emissions have been found, identified by satellite measurements. And they are found in these areas where lots of natural gas is being produced. Now, you know that the European Union, for example, where not so much gas is produced, but is used, they argue that, well, it is not a green energy source, but it's a transition greenish energy source. And when you look at this sort of explosive development, which really gets sort of out of control, and somehow you might wonder why this is never discussed. And I would be interested how many of you have ever heard or read about this climate catastrophe which might come due to permafrost melting from the methane stored in the ground. And the permafrost starts to grow even faster. And well, there's for example, a recent Nature article about it if you are interested in this. So now, if you look now at the average of the CO2 growth, and in somewhat more detail, there's a very interesting group of scientists who work together in the so-called Global Carbon Project, and they produce since years now the summary of what the situation is. And in this diagram, which was from the last year's report, you find really actually very interesting kind of things in the slope, and especially some areas where it became flat or even went down a little bit. And you see, well, there was the first oil crisis, of course, then the second oil crisis had a big impact, the collapse of Soviet Union and the related satellite states, so to speak. This had also an influence, but it was quickly overtaken. Then in 2008, there was a global financial crisis, which had also a good effect. And then we had the COVID pandemic and back. Now we are still to record heights. Now, when you think that we should soon be at kind of zero CO2 emissions, then you can imagine in our standard economy, what kind of economic crisis would this would imply. And I want to give you something more. Now, well, one is always talking, oh, there are the big emitter countries, and some countries are bigger than others. But I think the only fair way to really put it comes from the CO2 emissions per capita. And when you look at the top 6 emitters, average in the United States, and integrating this over the last 60 years or so, then you see by far the dominant country with emission of tons per person of almost 15 tons per person. Russia was also very strong, or Soviet Union, and after the collapse, you can see this had a big effect on reduction by something like 5 gigatons of CO2 emissions. And it's only very slowly growing. You might also see that United States is going down for several reasons, and the economy is not doing so great, which has some other consequences there also. Then you can see European Union, and here's China taking rapidly over, growing, but it's a per capita is almost a factor of 2 below United States, for example. And the world overall, 4.7. And in comparison, India is a very important contributor, but when you take it per capita, it's very small. And when you go for Africa, well, it's even smaller. So the impact of a person in Africa is maybe 20 or 30 times lower than the impact of a good European like us. And then you can see further, so we all like to use energy, and we enjoy to use energy. And you can see here, the largest contributions comes from oil, coal, and gas, and all the other are kind of tiny or minor. And for those who believe in the future of nuclear should see that there was a peak somehow, or a big plateau, and it's going down, and it's not even stagnant. And solar and wind and all these other things are very, very small. And okay, so the other issue, which we probably all have heard, is so-called ecological footprint and the Earth's overshoot day. And I would like to explain you that this is at best wishful thinking. And maybe some of you have even tried this so-called footprint calculator yourself and played around with this. You can do this here. It's kind of, actually it's very silly in my view how it's done, but you can try it and you will see how many Earths your lifestyle would require. But this aside, you can see according to this calculation on something like early August or end of July, the world uses more resources than are being produced. And this was repeated in FIS.org, so an article which is close to us about this, where we use 1.6 Earths annually worldwide, in richer countries something like 4 planets. Now, some of you might wonder how this is being calculated and what is not calculated. And actually, I had at a conference, I had an interesting conversation with Wackernagel. Sorry, Wackernagel is his name. I miswrote it here. And I was asking, so what happens if this overshoot day reaches January 1st, maybe a few minutes after midnight, a few minutes in the morning? And he looked at me and said, "What are you meaning?" And where we continue. So what is the meaning really? And then sort of when you go in details, and I find this sentence, well, it's pretty obvious, but in the frequently asked questions, I mean, I had some mail exchange with Wackernagel about this, but finally, I found it in the frequently asked questions. It's very difficult to find from the website, but you find it according on this link. There would be an alternative method to calculate the consumption of fossil fuels according to the productive area required to regenerate them. This would result in a carbon footprint many hundreds of times higher than the current calculation. Now, when you think about the sentence, so our footprint is not what they calculate really, because our life depends on all these fossil fuels we are using, and they are not non-regenerated, they are finite, as we all know. Then perhaps it's understandable why United Nations and many organizations like to use a simplistic footprint concept. But what I cannot understand is how scientists can be silent and accept such method and results and not cry out at least. Now, when you go in a little bit more detail in many years ago, 1971, in Science, Paul Ehrlich, a biologist, and G.P. Holden, physicist, they published an article on the so-called IPAT equation. You might remember that Holden was a science advisor in the Obama administration. And they came up with this idea that the whole impact, the human impact is the population multiplied by the affluence, multiplied by the technology. And this was a very interesting concept. Unfortunately, I think what is this equation, this is very useful, the equation, to understand certain problems, and that the population and the affluence cannot be compensated by technology, but it is sort of, at best, a qualitative guidance, as long as the so-called local or global carrying capacities for any particular species, including humans, or our local natural capital, is not being used in the equation. And actually, I was so much annoyed, and from my lectures, and I came up with a new modified quantifiable equation, and I had not found it anywhere discussed like this. So what I did, I published it right away, and I'm happy if you have time to read through this paper. The link is here, and I'm happy, of course, to answer all questions about it. But just in short, so I think what the real point is, what is the carrying capacity as a function of time on our planet? And you can say, well, it's the carrying capacity at a certain time zero, and then it gets reduced by the impact, and there's some restoration as well. And the impact can be natural reductions, like, for example, volcanic eruptions can destroy a whole island, so there's not much life afterwards. And then you have, in addition, this impact by this human, this IPAT equation. There's also some restoration. So you have natural restoration and perhaps human restoration. But in the moment, this human restoration is so small that it's unfortunately negligible. But perhaps here is a big point we all scientists can work on as well. Now, I think it should be pretty clear that the local and global sustainability principle is violated as long as the natural capital is destroyed faster than its restoration. And we should be very careful, because humans enjoy what is so-called the ghost carrying capacity. And this ghost carrying capacity is because we use non-renewable energy resources. Now, here I have a little diagram also from my paper about the depletion of the natural capital. Just, for example, how much I related it to oil, because I think oil is one of the most important ingredients. And when you take the resources which were formerly there, so basically in the year 2000, roughly, we had sort of used some 25%. And then you can estimate, or in the year 2000, you have 75%. And then you can estimate, if we have an annual growth, like we all like, let's say 5% growth, to grow out of poverty in some areas of the world, then the resources will quickly end. And if you grow by, let's say, 2% annual growth, and if we are lucky and have just a constant use, we still end of the full depletion around 2017. Now, this is just a qualitative diagram, but you can imagine and what the real usable resources are, and so on and so forth. So personally, I still believe oil is the weakest chain element, but I think many elements in our chain of life support system are already highly damaged. Okay, so just why oil is so important. Well, you know, almost nothing moves without oil, and the dependence on the industrial food supply chain, I think this is one of the most frightening numbers. 1 calorie of food is based on the input of 10 calories from oil and gas. So once oil and gas get scarce, where do our calories come from? And then this global trade economy is also basically 100% based on cheap oil. And of course, we have conflicts about the really area where 2/3 of the remaining oil, where 2/3 of the remaining good oil is in the Middle East, in a very small area. And obviously, who gets access to it will become the most powerful, or who keeps the access or the control of it will be the most powerful. So I'm convinced that we should actually learn very quickly to reduce, not only because of the CO2, but the CO2 numbers tell us probably now, because we wasted another 10 years, that we should go now down every year in the use by at least 5%. And if we want to even come close to what has been promised and what we all want to have, I believe this is CO2 issue. Now, this brings me close to the end now. So just what could be this responsibility of scientists or role of scientists and especially physicists? One might argue there are so many people, scientists working already on the issue, and it is enough, and we physicists, we have something better to do. Well, this you might argue about it, but I think we should all be careful with not following the suicide line much longer, at least not passively. And let me start with some quotes here, which I think indicate already what we should do or what we should not do. And starting with Richard Feynman, physicists learn to realize that whether they like a theory or they don't like a theory is not the essential question. Rather, is whether or not the theory gives predictions that agree with this experiment. So I think I have tried to show you that the evolution of our sustainable, unsustainable living shows exactly that we are on a suicidal war with nature. Then this is something I really found impressive. Science promised us truth, or at least the knowledge of such relations as our intelligence concised. It never promised us peace or happiness. But it means we should be honest and tell the truth, or at least as much as we understand or don't understand. And then there's Richard Leakey, one of those famous anthropologists who found many bones of our ancestors. And I do not know the answer, and I think this is equivalent to many of us. I do not know the answer, but I do know that we need to talk about the problem. Well, it was population problem in this quote, but I think it's in general. And when you think about the iceberg, so we might see the tip of the iceberg, but what is all below, this was destroying the Titanic. Now, I also do not know how to convince addicted people to change behavior. And I even less know how to convince crowds of addicted people, including myself, in this civilized life or civilization or whatever. But I think at least it seems that methods like the ones used by anonymous alcoholics work. And perhaps we can learn something from this. Now, the most simple idea, which I carry along with me for quite some time, is in order to accept our responsibility, there could be something which is surprisingly not there. Now, we know that the medical science, they have the so-called Hippocratic Oath. And my idea, or the idea probably of many others, is, or the question, why don't we have a similar code when we enter, or we get our university degrees, or we start working at a university, or we work since long at a university or scientific institutions? And just this sentence from this Hippocratic Oath: in whatever house I enter, I will enter to help the sick and will abstain from all intentional wrongdoing and harm, especially from abusing the bodies of men or women, bond or free. Actually, when you look up the Wikipedia article, there are some very strange things about this Hippocratic Oath. But after all, I think not that it will solve all the problems, but I think such a simplistic draft wording, for example, it would be very useful to have such a thing to make all scientists responsible for what is there. And I would be happy to formulate such a things together with people interested in this, and perhaps bring it into the public. But it could be something where we promise, so once we get our degree, we promise to tell the truth, or at least the knowledge of such relations as our intelligence conciles. We promise to speak about the destruction of the planet in the real overshoot situation. We contradict public lies with facts and stand up against fake solutions and promises by our political leaders and their scientific advisors. Like, for example, CO2 storage possibilities, negative CO2 emissions, alternatives idea violating for obviously the second law of thermodynamics, which are often given as a solution spoken out by many politicians in Germany, for example, during the last months from the government. And we should all help to reduce and stop the suicidal war against our life support system. All right, and this brings me to the summary slide. So you can see the pictures and imagine how life is great on the Titanic if you have seen this stupid movie and what is happening. Now scientists I consider to be on the so-called watchtower of what is ahead of us, and basically on the Titanic they failed to tell what is coming. But let me say, so to repeat what I had as a summary of my 2014 publication, which was published in this Science Elsevier, no, I don't remember even the journal title, Sustainability or something. In summary, and acknowledging that the probability to apply a successful application of the development towards sustainability roadmap, you see my wording. So this would make sense, have a development towards sustainability. If we are unsustainable in our way of life, I mean, what does mean sustainable development mean? So it is the opposite, actually. So if you have a development towards sustainability roadmap, this at least idealistically might give some result. But such a roadmap, we can imagine that this will be applied on a global level is very small. It can be stated and beyond doubt that our current policies and practices are leading absolutely inevitably to total collapse and to the extinction of countless of species, our own quite possibly included. And well, with this I want to close and say just, well, the iceberg collision has not yet happened, and so there is still some time left, but it is not much. Thank you very much for your attention.